All right, my friends, for problem 3, it says convert each polar equation into rectangular form, and for part A, theta equaling 4 pi over 3. I hope it makes sense that graphically that this would be a line graph. So if your R value can be anything at once, but your angle is locked in at, 4 pi over 3, that you would have a line graph. The identity that you would reach for, hopefully for this one, would just be the tangent of theta, which is 4 pi over 3, is equal to y over x. And then from there, you just need to evaluate for tangent of 4 pi over 3. So that would be the sine of 4 pi over 3, which would be negative square root 3 over 2, divided by the cosine of 4 pi over 3, which would be negative 1/2. There we go. And then it's just a matter of a little like canceling the negatives and then flipping and multiplying, canceling the 2's. And you'd end up with y over x equals the square root of 3. And which you're done at this point. It's all simplified and everything. But to really point out that you'd have a line graph, you could also just multiply by x. And then it should be pretty clear that you just have a line graph with a y-intercept of 0 and a slope of square root of 3, which is about 1.7. So there you go. Let's see. So scoring for that one. Let's see. We're going to give you 1 point for using this identity, tangent of 4 pi over 3 equals y over x. 1 point for evaluating the tangent of 4 pi over 3. And so, actually, you know what? Let's back up. Sorry. 2 points for using the identity. And then 1 point for a combination of evaluating tangent of 4 pi over 3 and simplifying it down to square root of 3 and getting to here. There we go. Okay, for part B, r equaling negative 6 sine theta. Different ways to go about it, but you would definitely want to replace sine theta with y over r, and then multiply both sides by r. So you'd end up with r squared equaling negative 6y. And then you could replace r squared with x squared plus y squared. And then at that point, you've done what they asked you to do. You converted it into rectangular form. So let's see. For this one, let's give you, it's 4 points. So let's give you 1 point for replacing sine theta with y over r. 1 point for replacing r squared with x squared plus y squared. And then 2 points for getting to something that's equivalent to this in terms of just x and y and no more r's and thetas. So that's your 4 points for that one. All right, part C is worth 6 points. R squared you could immediately swap out for x squared plus y squared. Now sine 2 theta, you would need to expand this using the double angle formula for sine. So you'd have 2 times sine of theta times cosine of theta. And then from there, you could replace sine of theta with y over r, cosine theta with x over r. And then simplifying this right side, you'd end up with 2xy over r squared. And then the r squared you could swap out for x squared plus y squared. At this point, you are technically done. A lot of people might clear the fraction on the right side by multiplying both sides by x squared plus y squared. And then their final answer would look like this. But either of the last two is just fine. Okay, so points for this one. You get 2 points for replacing sine of 2 theta with 2 sine theta cosine theta. You get 1 point for replacing r squared with x squared plus y squared. You get 1 point for replacing sine with y over r and cosine with x over r. So 1 point each. There we go. So 1, 2, 3, 4, 5. Oh, that's 5 points already. Wow. Okay. And then the last point is for getting to one of these two answers here at the end. points. Okay, now for part 4 here, graph the equation from problem 3, part B, on the rectangular coordinate plane below. There are a couple ways to do it. There's know that this is a polar equation for a circle with a diameter of 6. And then you could just, from here, you could just plug in some easy numbers. So like if theta was 0, r would be 0. If theta was pi, then r would be -6, so you're facing pi, but you go away from it 6. If theta was pi over 2, you know, you get 0 again. But even so, if you knew you were expecting a circle of diameter 6, just these 2 points of accuracy would help you to know that this is the diameter, and then your center could be here, and then you could see your radius is 3, 1, 2, 3, and just count 3 out from each direction. So that's one way to have done this one, would be to have just looked at the polar form, and then you could have gotten it. Another way to have done it would have been to complete the square on your answer here. So you like move the y terms together, and then kind of stick a 9 in there, balance your equation. And then depending on your experience with circle equations, some folks can tell here it's a circle with a radius of 3 because 9 is 3 squared. And then it got shifted horizontally, not at all, and then down 3. So that's one way to get it. Another way would be to just divide the 9 over and treat it like an ellipse, because a circle is actually an ellipse. So you'd have x squared over 3 squared plus y plus 3 squared over 3 squared equals 1, and then you can tell that you'd get this graph by shifting it down 3 and then going out 3 in all directions and then filling it in. So different ways to get to the same thing. So you get 1 point for having a circle graph. You get 1 point for having a radius of 3. And then you get, actually, let's give you 2 points for having a circle. There we go. And then from there, we'll give you 2 points for having the center at 0, -3. There we go. And that's your 5 points.